Okay, so this is a demo app that I'm going to show you. The first thing at the top we've got includes to the Azure Sphere DevX library. If we just scroll down through the application, you see we've got pretty much a standard function that you'll find in most Azure Sphere applications called init peripherals and handlers. And in that function, which gets called from from the main entry point, you'll see there's a call to Azure Connect. Azure Connect is responsible for connecting to Azure IT Hub or Azure IT Central, and it's responsible for maintaining a connection should the connection drop and re-establishing connection. You'll see that there's functions on here to initialize GPOs. There's subscribe function here for device twins. There's a direct method subscribe to direct methods. In the closed peripherals and handlers, again, pretty much closing the GPIO, unsubscribing from twins, direct methods, etc. Come down to main, the main entry point, you'll see that there goes the call to init peripherals and handlers, there goes the main event loop, and there goes the call to close peripherals and handlers should the application exit. Okay, so what we're going to do is create a very simple app which is going to send up telemetry to Azure IoT Hub. And I'm going to show you how this works. So the first thing I'm going to do is I'm going to paste in a binding. Now, what you'll notice with the Azure Sphere DevX library is that there's a really strong pattern. And the pattern is around bindings. And all a binding is a data structure. And that data structure has all the variables that are associated, in this case, with a timer. And what that means is that your code will also scale really well because you only have to declare that timer. It only takes one line of code, or in this case, two, because of it's wrapped around. And what that binding here is saying, it's this timer is going to fire every 2 seconds. The binding name is called publish message timer, and it's going to call a handler called publish message handler every 2 seconds. Now what we need to do is initialize that timer. So what we do is we add it to a collection or a set or an array of timer bindings. So I've added that variable here, publish message timer, by reference to the timer bindings. And if I scroll down to init peripherals and handlers, you'll see there's a function down here called timer set start. And what that would do is it will start that set of timers that are referenced in that array. Okay, so that's set up my timer. The next thing I need to go and do is implement the callback function or the handler for this timer. So we'll add a bit of space in here and we'll copy in some code. And this is the handler. And while I'm going to talk about that in a moment, we'll just deploy this application to the Azure Sphere device. So it's going to do a compile and then copy the application across. And you will see in the bottom right-hand corner, I've got an AVNet board which has built-in sensors, which we're going to read the data off and publish up to IoT Hub. Okay, so that application has now been deployed and the debugger is going to be connected in a moment. So the first thing this callback function will do, so remember this is publish message handler, which is going to be called by the timer when it fires every 2 seconds. First thing I'm going to do is I'm going to check, am I connected to Azure IoT Hub? If I am, then I'm going to go and read the data. Then I'm going to serialize that data into a JSON string, and then I'm going to publish that JSON string to IoT Hub. And if I pop across to Azure IoT Explorer, go and look at the telemetry, start up the watcher for that, you will see that there goes the data that's now streaming in to IoT Hub. And the IoT Explorer is a really easy way to go and explore what's going on with the telemetry. Okay, so we'll stop the application. And what I'm going to do now is I'm going to add in a direct method. So you'll notice on that AVNet board, there's a relay, and I've also got a torch hooked up to it. So you can see it being turned on and off. So what I'm going to do is I'm going to add in a GPIO binding. So scroll back up to the binding section, paste in the binding. Now, as I said, there's a really strong pattern. Things are called bindings. They are just data structures with a collection of variables which are related to GPIO in this case. So you'll see there's a pin number, there's a direction for the GPIO, the initial state, the name, etc. And I just go and add it to this GPIO bindings by reference. If I go and look at the GPIO bindings, scroll down to init peripherals and handlers, you'll see that does a GPIO set open. So it's going to open up the set of GPIO bindings. And then the next thing I'm going to do is I'm going to add in a direct method. So we'll add in the direct method. Scroll back up to the declaration section, paste that in, and you'll see I've now got another binding called direct method binding. It has a variable in there called method name set to light control. And what will happen is that when a direct method message comes into the device, if a direct method comes in named light control, then the handler called light control handler will be called. And this variable here, we need to make sure we add it by reference to this direct method binding array, which is called direct method bindings. And again, if we scroll down to the init peripherals, you'll see we've got direct method subscribe, and we're just passing in the array of direct method bindings. And what that means is when a direct method comes in, message comes in, we just iterate through that array of direct method bindings. If there's a match, we'll call its associated handler. Okay, so the next thing we need to do is just add in the handler for this. Paste that in, and I'll just kick off the compile and copy onto the Azure Sphere device. Okay, so you can see this is the handler called light control handler, and it's going to be passed in a JSON object. And this light control handler is associated with a direct method name called light control. In fact, while I'm there, I'll just copy that. And what we're going to do is we're going to deserialize the JSON object. It's going to be, which is a payload for that direct method. And then ultimately, we are going to deserialize that object down to a Boolean. And then we're going to set the state of the GPIO to either on or off. So I'm going to pop across to, I'll just make sure that copied properly. We'll pop across to the IoT Explorer again, and we'll go to direct method. And we'll paste in the name of the direct method, and we'll paste in the JSON payload. And paste that in there, and now I'm going to invoke that direct method. Remember I set a breakpoint in that callback function, and you can see that breakpoint there is at the GPIO set state. F10 to step over that, and voila, the light turns on. Okay, so we'll just let that callback complete. And we're going to set, and that we're just going to turn the light off. We're going to set the light state to false, invoke that function. And the callback gets called on my Azure Sphere application, and that will turn the light off. So keep in mind that I'm using the IoT Explorer really as a proxy for the application that you would go and build. You would obviously normally build an end user application or a backend service which will be controlling these, but this is a nice, using the IoT Explorer is a nice, easy way to go and interact with our functions, our direct methods, twins, and telemetry. Okay, so the next thing I'm going to do is I'm going to set up a device twin. And shouldn't come as too much of a surprise, but I'm going to paste in something called a device twin binding. So I've got a device twin binding here, and it's called sample rate device twin. The device twin property name is called desired sample rate in seconds, and it is of type int. And what happens when a message comes in, if there's a matching name, I also do a check to make sure that the type is correct. And on the base, there's a match in the name and on the type, then the handler will be called. And the handler is called sample device twin handler. So what we're going to do now is, well, we need to go and initialize that. So we need to go and add that by reference to the device twin bindings array, and it won't come as a surprise. Go down to init peripherals, and you'll see that there is a function down here called device twin subscribe, passing in that device twin binding array, and then basically that array is iterated through when a device message comes through, twin message comes through, finds a match, calls the associated handler. Speaking of which, we're now going to implement the handler. So here goes the handler, and I'll just put a breakpoint. But let me just stop the application, and we'll kick that application off again. So it's doing a build, and that is now copying the application across to the Azure Sphere device. and it will start up the associated debugger. So you'll see what happens with this callback. So in the signature for this the handler, what is passed across is the device twin binding. And then with a bit of C in here, what we're doing is basically casting the twin state to an int pointer and then dereferencing that. And then we will get the value of sample rate in seconds. And then we do what all good applications should do. They should validate the input. So in this case here, we're just making sure that the sample rate seconds is greater than 0 and is less than 5 minutes. And then what we're going to do is we're going to change the timer. And the timer is associated with the publishing message timer. So what we're going to do is we're going to pass that by reference, and then we're going to change the timer to the sample rate. And then because this is an IoT plug-and-play application, we're going to respond back with an acknowledge of the desired state back to IoT Hub, which will update the device twin. So what I'm going to do now is I'm going to pop across to IoT Explorer, and I'm going to go into the plug-and-play components. Now, this application has actually been plug-and-play enabled, and I'll go to Properties, and down here you'll see that there is a schema for desired sample rate in seconds. And I'll go and set that to 2. Now, what I had meant to do is put a breakpoint in that device twin handler. And we'll pop across back over here to the Explorer. We're going to update that device twin. And you'll see what's happened now is that the event handler got called. The handler got called, I should say, for this device twin. We can step through the code. We should have sample rate now set to 2 seconds, and that will set that publishing rate now to 2 seconds. We go across. In fact, let me just set one more. Do that again, and again we just step through the code F10, and we'll see sample rates set to 5, etc. And now what you'll see down here in the device output, you'll see the applications now sending telemetry every 5 seconds. So you'll see that's at 4:53. It's now at 4:58. So every 5 seconds. So anyway, hopefully that gives you an idea about how the Azure Sphere DevX library works. I've obviously only shown you a small element of the overall library, but it's very much around this concept of bindings. And you're going to declare these bindings, you're going to initialize these bindings, and you go and set up callbacks. And then you just have to go and fill in the callback with your application logic. You don't have to worry about how device twins get called, how to deserialize data, how to check the type. All that stuff is done for you as part of the library. And of course, you can go and dig into the library and understand how it all works. So all the source code's there. Press F12 in this case here. We're going to look at a device twin binding. And you'll see kind of the stuff you'd expect. The device state, the property, has a device twin been updated and things like that. Anyway, so hopefully that gives you a pretty reasonable idea about how the Azure Sphere DevX library works. Thanks so much.